All right, so today we are going to be talking about properties of quadratic graphs. We also call them parabolas, and this is chapter 8 in our textbook. So first we have a do now, so please pause the video, complete the do now, and then resume when you're ready to check your answer. So if you're listening to my voice, that means you completed the do now and you're ready to check your answer. So the question poses is, does the coordinate point 4, 3 satisfy the equation y equals 3x squared minus x plus 7? So all we need to do is to substitute in the x and the y values and see if we get a true statement. So we're going to do that right now. So the y value is 3. So I'm going to substitute y for 3. And I'm going to substitute my x value for 4. So I get 4 squared minus 4. And now we're just going to simplify. Well, 3 just drops down. Now we get 3 times 4 squared. That's going to be 48. And then minus 4 plus 7. And clearly, just by looking at it, you can see, no, it doesn't, but we need to prove it. So 48 minus 4 is 44. 44 plus 7 is 51. And we get 3 does not equal 51. So no, 4, 3 does not satisfy the equation. Perfect, beautiful, nice job. So today's essential question is, how can you graph a function that's in the form f of x is equal to ax squared plus bx plus c? We also can see that as y is equal to ax squared plus bx plus c as well. So here is one of the core concepts, so please pause the video, copy down the notes, because I'm going to be drawing on them as we go through, and resume when you're ready to hear some notes explained. All right, so we have a couple of things to talk about. First, the graph opens up when a is greater than 0, and the graph opens down when a is less than 0. Pretty much what that says is when your a value up here is positive, it's going to open up like this. When your a value is negative, it's going to open down like that. Okay, you can think about it as facial expressions. When your a is positive or your mindset's positive, you're going to smile. It's going to open up. When your a value is negative or your mindset is in a negative spot, you're going to be frowning. So your mouth is going to make a frown. So it opens down. The next thing we need to talk about is the y-intercept is going to be c. On the graph, it's right here on the y-axis. Just like in slope-intercept form back when graphing linear equations, your b value was your constant. So that was going to be your y-intercept. Likewise, your c value here, your constant term in a quadratic equation, is going to be your y-intercept. Next, the x-coordinate of the vertex is going to be negative b over 2a. Okay, your vertex is way down here. Your vertex is down here, okay? We're going to use the equation negative b over 2a, and that's going to give us the x value of the vertex. Then we plug it in. So we're going to take that x value, plug it in to the equation to find the y value, just like we would in any other equation. We have our x, we use it as an input, and we get the y value. Now, the last thing we need to talk about is we have what's called the axis of symmetry. Okay, the axis of symmetry, notice, is going to be x is equal to, well, the x value of the vertex. Negative b over 2a is the exact same equation. So your axis of symmetry goes through the vertex at the x value of the vertex. This is going to be your axis of symmetry right here, this dashed line, because a parabola is symmetrical. So we can create the axis of symmetry. Notice it's a vertical line going only through the x-axis. Okay, so the axis of symmetry is the x value of the vertex. Let me jot that down. X value of vertex every single time. Every single time, the x value of your vertex is going to be the axis of symmetry. And let's do an example with that. So it says A, find the axis of symmetry, and B, the vertex of the graph of 2x squared plus 8x minus 1. So we always want to find the axis of symmetry first because we're finding the x value. So the axis of symmetry, again, is negative b over 2a. So we plug in our values. Well, 2 is a, 8 is b, and negative 1 is c. So we plug in what we know. Well, it's going to be equal to the opposite of my b value. So it's the opposite of positive 8 over 2 times the a value, and the a value happens to also be 2. Fix that, perfect. So we get negative 8 over 4, which is equal to negative 2. This is, again, the x value of my vertex. It's the axis of symmetry, but it's also the x value of my vertex. So I can use that now. So to find the y value, I need to plug in 2 for x. Or negative 2 for x, I should say. So I'm going to take this and I'm going to plug it in. So we get 2 times negative 2 squared plus 8 times negative 2 minus 1. Well, negative 2 squared is 4, so 2 times 4 is going to be 8. We have 8 times negative 2, which is negative 16, minus 1. So all in all, we get 8 minus 16, which is negative 8, negative 8 minus 1, which is equal to negative 9. So my vertex is going to be negative 2, comma, negative 9. That's our final answer for B. Awesome job. So proud of you. All right, here are 3 problems for you to try out on your own. Try them out, and then I'm going to show you the answers in the next slide. Perfect. So here are the answers to the 3 problems that I asked you to attempt. Okay. Notice, again, that the x value of your vertex is the axis of symmetry every single time. Awesome. Great job, everyone. Doing so well. Okay, we have another concept that we want to talk about. So the maximum and minimum values, okay? So the y-coordinate of your vertex of a graph, again in the form ax squared plus bx plus c, is the maximum value, let me highlight that, is the maximum value when a is less than 0, okay? So it's a maximum, again, when a is less than 0. Noticing that since my a is less than 0, we're opening down. That means it's going to be a negative a value. Likewise, it's a minimum value when a is greater than 0. So notice that my a is greater than 0, so it's going to be a positive number, meaning it's opening up. Pretty much what this is saying is that the y value of your vertex is going to be the maximum. If it's opening down, it means it's the top point of the graph. And likewise, for a minimum, it's the bottom point of the graph. So let's dot that. Top of graph, bottom of graph. Okay, every single time. If your parabola is opening down, your vertex is going to be the maximum. If your parabola is opening up, then your vertex is going to be the minimum. Now, there's 2 other small topics that I want to talk about, domain and range. So let's extend this. Here we go. So the domain, again, is all x values. And the range, all y values. So when we talk domain for quadratic equations and the graphs parabolas, 99% of the time, it's going to be all real numbers. Actually, you know what? Let me erase that and actually write out the word numbers. Because these graphs go on forever. So it's gonna use every single x value possible. The only time it wouldn't be all real numbers is if you're given the graph on a coordinate grid and it stops. It says, okay, we're ending at these two coordinate points. Then that would be the only time you say, oh, it all the way to the left is like -3, and all the way to the right is like 8. Okay, but 99% of the time it's going to be all real numbers. Your range, though, is going to be the y value of the vertex. Okay, if you have a minimum value, then it's going to be y is greater than or equal to the number of the vertex. And if it's a max, it's going to be y is less than or equal to the number. And if we go back up and we look at these graphs, well, if I'm looking at the maximum, well, yeah, this is the highest point, and all these y values down here are all possible. But I can't go above it, so it's going to be y is less than. Likewise, if I'm looking over at the minimum, my graph is hitting all these y values and is getting bigger. So if it's a minimum, it's y is greater than or equal to. If it's a maximum, it's going to be y is less than or equal to. And that's how you find domain and range. Again, domain 99% of the time is going to be all real numbers. In the range, if it's a minimum, it's y is greater than the y value of the vertex. If it's a maximum, it's y is less than or equal to the value of the vertex. Let's do a quick example. So it says describe the domain and range. So again, a domain, if I'm not given the graph, it's going to be all real numbers. And for my range, I need to find the vertex. So in order to find the vertex, I got to have x is equal to -b over 2a. My b value is -6, so it's the opposite of -6. So I get 6 over 2 times 3. So I get 6 over 6, which is 1. But now I need to use that value of 1 and plug it into the equation to find the y value. So we have 3x squared minus 6x plus 5. We plug this 1 in for x. So we get 3. Sorry, let me just jot it down first. That way I can save some time. We plug 1 in for all of the x values. So 3 times 1 squared minus 6 times 1 plus 5. Well, we get 3 minus 6 plus 5, which is then going to be equal to -3 plus 5, which is +2. So it's going to be the y value is now 2. So this is my y value. So now we need to go back and look at the a value. Well, my a value is 3. That means it's positive. So my a is greater than 0, meaning it's going to be opening up. It opens up like this, which means I'm going to have a minimum. So my range is going to be y is greater than or equal to 2. Because I have a minimum, that means the lowest y value possible is 2. So y is greater than or equal to 2. Awesome job. With that in mind, here's 3 problems for you to try out. Okay, I'm going to show the answers on the next slide. So try these out and then we'll see how it goes. Here are the answers. Okay, again, notice the domain is all real numbers for each one. And now what I did was I used h of x instead of y, k of x instead of y, and p of x instead of y, just because they gave h of x is equal to da-da-da-da, k of x is equal to da-da-da-da, p of x is equal to da-da-da-da. Okay? If you have y is equal to, I'm totally fine with that as well. 6 to 1, half a dozen the other. Here is your closure. Okay, try it out, and then make sure you answer this on the Google form attached to class. Everyone, great job. So proud of you.